What if the secrets of our planet's past, and even its future, are buried beneath miles of ice? Antarctica has long been a frozen enigma, but recent findings suggest this remote land may hold clues to ancient epochs and looming destiny. Even the first explorers were stunned by what they found on the icy wastes. In the early 1900s, Robert Scott's team, trekking toward the pole, uncovered fossilized plant remains, leaves bigger like beach leaves, more than 500 kilometers from the South Pole. These organic remnants, buried under former glaciers, proved Antarctica once grew forests.
History is not just the past. It is the greatest story ever told. From the rise of mighty empires to their fiery collapse, history has shaped the world in ways that continue to amaze us. From warriors who carved kingdoms to revolutions that changed the course of civilization, every moment holds a story worth remembering. If you have ever wanted to see history as if you were truly there, you have found the right place. Step into the past, relive the greatest stories ever lived, and join our journey through time. Subscribe now.
At first, Victorian scientists dismissed the finds as mistakes, but we now know the continent has preserved real evidence of a far greener past. Geology makes clear, Antarctica was once radically different. Paleontologists have dug up petrified trees and swamp sediments dating hundreds of millions of years ago. For example, a 2016 expedition found 13 fossilized tree trunks over 260 million years old, proof the coldest, driest continent was once densely forested. Climate models and isotope data show Antarctica then was warmer and wetter, with ecosystems more like Siberia's boreal forests than a polar desert. Even dinosaur bones and pollen grains turn up in the rock record, whispering of lizards and ferns under polar daylight millions of years before humans arrived. A popular myth holds that an unknown civilization thrived on an ice-free Antarctica, but hard evidence says otherwise. Scholars note that ancient maps like Piri Reis's 1913 chart depict a southern land only by coincidence. In reality, Antarctica has been ice-covered for about 15 million years, long before humans. When media hyped a pyramid on Google Earth in 2016, geologists showed it was simply a peaked mountain eroded by ice. In short, serious scientists have found no sign of human artifacts or constructions under the ice. As one Nature commentator quipped, Antarctica has become a screen on which to project its fantasies. But every conspiracy, Nazi bases, alien spaceships, etc., has been debunked by real explorers and historians. In 1946-47, the U.S. launched Operation High Jump, the largest Antarctic expedition ever. 13 ships, 23 aircraft, and about 4,700 personnel mapped huge tracts of West Antarctica. Officially, it was a scientific training mission, but declassified orders reveal a secret aim: establish a basis for U.S. territory in Antarctica. This massive Cold War venture returned with extensive aerial photography and new charts, but also a cloud of rumors. Conspiracy theorists later claimed the fleet battled hidden Nazi bases or even UFOs. Historians, however, have shown these stories to be baseless folklore. In reality, the 1930s German Antarctic expedition had only built a whaling camp, and high-jump scientists found no secret weapons, only more ice. A decade later, nations chose peace over conflict on the ice. In 1959, 12 countries signed the Antarctic Treaty, turning the entire continent into a natural reserve devoted to peace and science. The treaty, now ratified by over 50 nations, bans military activity and nuclear tests in Antarctica and freezes all territorial claims. All Antarctic lands south of 60 degrees S must be used only for peaceful purposes. Nations agree not to pursue new sovereignty disputes. Scientific research is guaranteed free exchange. In effect, the treaty system has created one of the world's few demilitarized zones, preventing any power play over resources. As one commentator notes, it remains one of the most successful international agreements, preserving Antarctica's neutrality even amidst Cold War tensions. Still, myths of secret labs linger. In truth, most activity on the ice is public and regulated. Today, over 80 research stations dot the continent, all built and operated openly by countries around the world. For example, the US, Russia, China, and others each maintain a handful of stations under treaty oversight. There is no evidence of hidden bases or alien hangars. As nature reviewers have shown, fanciful claims, Hitler's Antarctic U-boat base, underground nuclear bunkers, etc., collapse under scrutiny. The polar environment does invite secrecy. Test sites are remote, weather severe, but international inspections under the treaty make any large-scale cover-up virtually impossible. In short, aside from routine classified experiments, limited climate or communications projects, nothing supernatural is under the ice. Ancient ice drilled from Antarctica is like a time capsule of Earth's climate. For decades, scientists have extracted core samples and read the tiny bubbles of air trapped inside. These records show that for at least 800,000 years before industrialization, atmospheric CO2 fluctuated only between about 180 and 300 parts per million. By contrast, today's CO2 level has surged past 420 ppm, a level unprecedented in any ice core record. In November 2025, a breakthrough came. Researchers recovered ice dated to about 6 million years old. The oxygen isotopes in that ancient ice reveal Antarctica has cooled roughly 12 degrees Celsius since then. Together, these deep climate snapshots calibrate our models. By comparing past greenhouse levels and temperatures to modern data, scientists better predict how ongoing warming will reshape global climate. Antarctica hides not just ice, but water beneath its shelves. Today, scientists know of hundreds of subglacial lakes, dark reservoirs sealed under kilometers of ice. To date, 400 such lakes have been mapped under the Antarctic ice sheet. A recent survey even cataloged around 700, including remote valleys. These pools contain a substantial fraction of Earth's liquid fresh water, yet they are isolated from the atmosphere. Remarkably, life still thrives in them. Microbial surveys of Lake Whillans and others have found extremophiles, salt-tolerant bacteria and archaea eking out energy in total darkness. Each lake forms its own closed ecosystem where biochemical interactions between rocks, water, and ice sustain microbial food webs. Studying these alien habitats teaches us how life persists under extreme cold and low nutrients. These hidden Antarctic worlds have even broader implications. NASA astrobiologists point out that subglacial lakes are excellent analogs for icy ocean moons, like Europa and Enceladus. Developing drills and probes to sample Lake Vostok or other buried seas helps design the technology to reach subsurface oceans on Jupiter or Saturn's moons. Moreover, Antarctic extremophiles demonstrate life's tenacity. The enzymes and metabolisms that allow microbes to live in sub-zero, highly saline lakes give clues to what to look for on other worlds. In short, Antarctica's extremes serve as a natural laboratory for astrobiology. By revealing how life survives under thick ice at Earth's poles, we learn how it might survive beneath the ice of distant planets. Antarctica's modern story is one of rapid change. Nowhere is this clearer than Thwaites Glacier in West Antarctica, nicknamed the Doomsday Glacier. Thwaites flows into the Amundsen Sea and alone contributes about 4% of all global sea level rise each year. It spans roughly 120 kilometers, size of Florida, and holds enough ice to raise sea levels by roughly 65 centimeters, 25 inches. If it fully collapsed. Glaciologists warn that parts of Thwaites and neighboring Pine Island Glacier are already thinning and retreating. Even partial collapse could commit the planet to meters of sea level rise. In fact, recent studies show the glacier's grounding line is receding faster than models expected, underscoring that worst-case outcomes, several meters rise, are no longer implausible. Every foot of Antarctic melt translates into flooded coastlines. New York, Shanghai, Mumbai all sit on that frontier. As Antarctic ice melts, fresh water pours into the Southern Ocean and begins to alter ocean circulation. Fresh meltwater and increased precipitation have actually cooled the Southern Ocean's surface over recent decades, contrary to earlier projections. This occurs because the low salinity lid of meltwater insulates the surface from warmer, deep currents. Yet the Southern Ocean is a climate powerhouse. It absorbs a quarter of human CO2 emissions and over 90% of excess heat, and it helps drive global weather patterns like El Niño and La Niña. Stanford researchers warn that current meltwater trends are already altering ocean dynamics and possibly the global climate. In practical terms, slowing the Antarctic-driven ocean conveyor could weaken the Gulf Stream and shift rainfall belts, potentially bringing droughts or floods far from the poles. Antarctica's meltwater is thus more than a local event. It is a trigger for system-wide climate dominoes. Melting ice also exposes mineral and hydrocarbon deposits long locked under snow, tempting a future scramble. Under the 1991 Madrid Protocol, Antarctica's mineral resources are off-limits. Commercial mining is completely banned. That ban can only be lifted by unanimous agreement, and experts argue a 2048 review is unlikely to overturn it. But consider, if oil or rare metals were discovered as ice retreats, climate-strained nations might lobby hard to exploit them. Already, companies propose drilling test wells on the continental shelf. In the meantime, wildlife agencies face similar pressure over fisheries. Krill and fish quotas are politically contentious as demand rises. Conservationists warn that once the ice barrier is breached, Antarctica's remote riches could become targets. The continent's future may hinge on global choices, whether to allow a new northwest passage of minerals and oil, or to keep it a preserved sanctuary. A new era of exploration is dawning, led by innovation. In recent years, researchers have deployed autonomous drones, underwater robots, and AI-driven satellites to probe Antarctica more thoroughly than ever before. For example, a 2024 experiment at Rothera Station used unmanned aerial vehicles to map glaciers and monitor atmospheric gases remotely. Machine learning now sifts through petabytes of data: satellite imagery, ice-penetrating radar, seismic surveys, far faster than humans could, reportedly cutting field operation emissions by as much as 90%. These tools allow scientists to survey vast ice shelves, track changing crevasses, and even drill deep cores in extreme conditions with minimal environmental impact. In short, tomorrow's discoveries will come not just from boots on snow, but from high-tech eyes and probes that can reach where people can't. As technology opens Antarctica up, a tug-of-war is growing between conservation and exploitation. One front is tourism. In 2023 to 2024, more than 124,000 visitors made the voyage south, up from under 8,000 annually in the 1990s. While most tour ships follow strict guidelines, a new study found that pollutants, nickel, copper, lead from engines and infrastructure in heavily visited areas are now 10 times higher than 4 decades ago. Such contamination accelerates local snowmelt and threatens the continent's fragile ecosystems. Behind the scenes, treaty nations argue over how to manage fisheries, establish marine preserves, and enforce environmental rules. These debates mirror global climate politics. Should Antarctica be an exploited frontier of resources and tourists, or a preserved wilderness? The Antarctic Treaty and the Commission for the Conservation of Antarctic Marine Living Resources, or CCAMLR, strive to tip the balance toward protection, but the pressures are growing. Ultimately, Antarctica's fate is a mirror of ours. This pristine continent has no government of its own. It belongs to all humanity, which creates a sense of shared stewardship. As the treaty declares, Antarctica is devoted to peace and science, a place where humanity agreed to set aside war and rivalry. Its glaciers regulate global sea levels, its climate record teaches us Earth's limits, and its ecosystems are intertwined with the planetary web. How we treat Antarctica will echo back home. Melting ice means higher seas, altered weather, and lessons about survival. In that way, Antarctica stands as both a beacon of international cooperation and a stark warning of unchecked change. It is up to us, scientists, policymakers, and citizens worldwide to heed that warning and protect this last wilderness. For in safeguarding Antarctica, we safeguard our own future.